To understand how to use color, you need to understand its fundamental components. Hue is the first component. It's the color itself, often represented on a color wheel. This is the traditional color wheel used for centuries in painting, with primary colors being red, yellow, and blue. The true visual color wheel is a slightly different set of primary colors from the traditional color wheel for complex reasons. Instead of yellow, it uses green. There are three main methods of picking colors in Microsoft products. They're pretty universal to all computer software. The first method is playing with numbers in color models like HSB, CMYK, or RGB. I'm going to talk about these in depth in a later slide. Then there's using a color wheel, where the intensity increases as you move to the outer parts of the circle. And finally, there is using a linear spectrum, where the intensity increases towards the middle and goes to either gray or black on the edges. There are also crayons in Apple or Windows color dialog boxes that are not shown here. Pause the video here and take the Skills Application Challenge. At this point, it's enough for you to just find these panels in a Microsoft product or whatever graphics program you use, and remember how to find them in the future. Then unpause the video and go to the next slide. I'm going to cover the underlying concepts for these shortly in the video. At that point, you can go back and play around with these panels to gain confidence in using them. There are 12 principal colors. These are the 12 principal colors used in the art and graphics world. These 12 colors are exactly 30 degrees apart from each other. Saturation is the second component. It's also known as chroma. Saturation is the intensity of the color. You can visualize saturation as the amount of gray pigment mixed into the color. You can keep adding gray pigment until it completely neutralizes the color and there's no discernible trace of it. This slide illustrates the concept of saturation. This bar shows what it looks like if hue and brightness are held constant and saturation is increased from left to right. On the fully desaturated 0% left end of the bar, it's pure gray, and on the other side it is 100% saturation. In other words, the pure color with no gray ink mixed in. Brightness, also known as luminance, is the third and final basic component of color. Brightness is, just as it says, the brightness or darkness of a color. You can visualize brightness as the amount of black pigment mixed with the color. You can keep adding black pigment until it completely darkens the color and there is no discernible trace of the original color. This slide illustrates the concept of brightness. This bar shows what it looks like if hue and saturation are held constant and brightness is increased from left to right. On the 0% brightness left end of the bar, it's pure black, and on the other side is 100% brightness, in other words, the pure color with no black ink mixed in. This is a typical color wheel that you might find in graphics software. You can control hue and saturation within the wheel by moving your mouse around until you find the color you want, and then click. Saturation decreases as you move towards the center of the wheel. But brightness is a third dimension that cannot be represented on the two-dimensional wheel itself, so it has to be a separate slider control shown here. It's important to understand that brightness is independent of saturation. A color could be fully saturated, meaning at its full intensity, but very dark or light, like a light or dark red. Or it could be very grayed out, in other words, have low saturation, like a grayish red, but be very bright or dark. Adjusting saturation will get you to pure gray, but will not get you to black. Only brightness will get you to pure black.